Exercise 406, comparing data sets using dot plots. What I've just done is grabbed, using plots. So we're going to be looking at stem and leaf plots. In your textbook there are dot plots that are compared, and we're also going to be looking at box and whisker plots. Alright, so box and whisker plots you looked at last year. Alright, so this is just a HSC question. This back-to-back stem and leaf plot displays the test results. So the difference between year 11 and 12, is that you'll have back-to-back stem and leaf plots. So if you look here, notice this is 44, 47, 49. The numbers have to be written backwards on the left-hand side because you've always got the smallest number near the stem. So this is 52, 52, 54, 56. The first question is, what is the median? So there's 26 students. That means boys and girls. What is the median test result for the class? For the class, not the median for the boys or the median for the girls. I'm just going to pause, have a go. Median is the middle. You have to place them all in order. We're not going to write them all out. It's multiple choice. We haven't got time. 26 students. How do I find the middle student?
13.
13 on the left, 13 on the right. The median will be here. So we're going to count 13 students, put a line, and there should be 13 students after it. But be careful. We've got to do the boys and girls together. So I've got 1, 2, 3, 4. Do you know what I'm doing? 5, 6, 7, 8, 9. Do you know why I jumped over for 8? Because 3, that was 33. So I went 1, 21, like 1, 2, 3, 4, 5, 6, 7. This 7 is 33. That's 33. That's the 8th score. 35 is the 9th score. What's the 10th? 10, 11, 12, 13.
So it's between 45 and...
Be careful. This is really terrible. It may actually be a good idea to write the 4-row out. All right? Not a bad idea. Look, I'm going to write, you've got 44, 44, 44. Do you get it? 45, 47, 49, 49, 49. I have written out the stem for the stem and the leaf for the 4s. Do you get what I've done? I've put them all together. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Got it? 10, 11, 12, 13. Put a line.
6.
So yes, it's 6. It's 46. All right, because it was too hard going from one side to the other. So the median is the average of 47 and 45 and 47, which is 46. All right. Okay. Now that's not a very typical sort of question. That was back in 2010. Let's have a look at 2011. Question 25D. Data was collected from 30 students on the number of text messages they had sent in the previous 24 hours. The set of data is displayed, and they want the outlier and they want the interquartile range for the females. Now, you're lucky they've asked the females. I'm also going to do the interquartile for the males because they're backwards. It's a good... So they've asked for the interquartile range for the females, which is fine. It's forward data, but I'd like to do it for the males as well, all right? So, the outlier. What's the outlier? And 71. It doesn't say show that it's an outlier, prove that it's an outlier. You don't have to do the formula.
How would you prove?
We would use the formula that it's greater than 1.5 times the standard times the interquartile range. We did it last lesson or 2 lessons ago. Exercise 4.05, we use the formula outlier. It's an outlier if it's greater than Q3 plus 1.5 times interquartile range, and it's an outlier if it's less than Q1 minus 1.5 times interquartile range. Let's look at the next question, the interquartile range for the females. How many females? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 females. Right, let's divide them up. What do? 7 on the left, 7 on the right. That's the median. Now what do I do? You can't halve 7, so what do? 3, 3, 3, and 1. Are we good with those bottom 7s? And we've got 3. Half of 7 you can't do. Half of 6 is 3, 3, 1. That's Q1, that's Q3. If you wanted to work, so the median is 1, 2, 3, 4, 5, 6, 7. Put a line. Yes, the median is 17. But we want Q1 and Q3. 1, 2, 3, put a circle. 1, 2, 3. Can you see? 1, 2, 3, put a circle. 1, 2, 3. Interquartile range for the females. So Q1 for the females is what? No, it's 11. Q3 is 20. The interquartile range is 20 minus 11, which is 9. Look, I want to do the males as well because they're backwards. And you've got to be careful when going backwards. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 scores for the males. So for the males, we've got 16. How are we going to break them up? 8 and 8. Put a line. That's the median. So 1, 2, 3, 4, 5, 6, 7, 8. Put a line. 1, 2, 3, 4, 5, 6, 7, 8. Now what are we going to do? 4 and put a line. 4 and 4, put a line. So we want 1, 2, 3, 4, put a line. We got it? Be careful when you keep counting. You show me where the Q3 is for the males. So I went 1, 2, 3, 4, put a line. 1, 2, 3, 4, put a line. 1, 2, 3, 4. I count from 0. You must start at the stem. So I go 1, 2, 3, 4, then put a line. I don't come this way. You don't come from the left when you're going backwards. You start at the smaller numbers. See? 1, 2, 4, 5. Got it? This is 10 and 11. You don't start from the right, from the left going to the right when you're working backwards. You've got to go backwards. Always the smallest numbers. So what's Q1 for the males? That's the median. Yes, 14. Oh no. It's 1, 2, 3, 4, put a line. It's the average of 15 and 15, which is 15. It's between 5 and 5. Oh, it's 5. 0, 5. Sorry. And Q3 is what? Sorry, it's 0, 5. What's Q3? Come on. It's the average of 10 and 11, which is 10.5. So the interquartile range is 10.5 minus 5, which is 5.5. Do you notice the outlier doesn't affect the interquartile range?
Yes.
What? Quartile range. So your interquartile range gives you, here, that's your first quarter, your second quarter, your third quarter. When you do Q3 minus Q1, you're omitting the bottom 25% of scores and the top 25% of scores. It's like you're doing a range, not highest minus lowest score, but a quarter of the way, like 3/4 of the way minus a quarter of the way. So outliers will be excluded, and it gives you an idea of where the middle 50% of the data, how spread out it is. Can you see the interquartile range for females is higher than the interquartile range for the males? So even though the males have this outlier here, if we ignore this outlier, the males are actually more closer together because the interquartile range for the males is lower and the interquartile range for the females is higher. So they're more spread out. And you can see they sort of go, if you're ignoring any outliers, the males are going from 1 to 20, females are going from 6 to 34, sort of. But that's the range. But you know, that we're missing out the outlier. The ages of members of a dance class are shown in this back-to-back stem and leaf plot. Just having a quick look at it, look at where most of the men are, and look at where most of the women are. Just overall, just having a quick look, would you say there's generally the women are older than the men? You know, we've got clustering around the 50s and 60s, and it seems that the men are sort of in their 40s, late 30s, 40s. And that we can look at that in terms of skewness as well. So it says, Pat claims that women who attend the dance class are generally older than the men. Is she correct? Well, we're thinking yes, but we can't just say that. We need to justify our answer by referring to the median and the skewness. So let's start with the median for the women. Median for the women. Let's do the median for the men. Okay, you know what to do? Off you go. So I've got 13 women. How are you going to split them up? 6, 6, and 1. So I'm looking for the 7th. You must work backwards. 1, 2, 3, 4, 5, 6. Circle the 7th number. So there's 1, 2, 3, 4, 5, 6. Then we circle 1, 2, 3, 4, 5, 6. That's correct. So the median is 55. The median for the men, sorry, I've already started that here. 9 men, 4 on the left, 4 on the right, 1 in the middle. So it's the 1, 2, 3, 4, circle the number. So the median for the men is 45. So it does look like the median for the women is 10 years older. But let's look at the skewness. So this is what I'm going to do now for skewness. I'm going to turn it sideways for men. Have a look at men. Positively or negatively skewed? Good. No, positive. Start off on a positive note. Most of the men's data is at the beginning. Start off on a positive note. So the men's data or scores is positively skewed. Right? So the data for the men is positively skewed. Ooh, you've really got to be careful. Guys, I know we're looking at that like that, but you can't look at it like that because that's backwards graph. So it's actually negatively skewed for the men because you start...
What?
It's actually...
Positively.
Let me write out the data. You're not meant to write the data out like that. I really should be going... If I did men, just watch. If I did women in a column graph, the 30s is 1 high, for example. The 40s is 2 high. The 50s goes 6 high. Watch. Like that's even higher. And the 50s are 6 high and the 60s are 4 high. Now that to me looks like more of the data is at the back. So that means it's negatively skewed. So the women's data is negatively skewed.
That's what you said.
Yeah.
And then you thought you were wrong.
So if the men's data is positively skewed, it means, because, you know, you're supposed to start with lower ages to higher ages, it means that the men tend to be younger because you would put it on a scale. Yeah, so meaning that the men are mostly younger. The women's data is negatively skewed, meaning that the women's ages are more towards the older end, are older. There's less young people, meaning women's ages, more women's ages. More women's ages are older, meaning more men's ages are younger. Does it make sense? Like most of the men are young and then less of them are old, but here not many women are young, but more of them are older. So now we've got two things. We can compare the medians. So therefore the women are generally older. Women are generally older than the men due to higher median and negative skewness. Higher median, I'd say 10 by 10 years.
Miss, do we have to give working out?
Yes, you must give working for medians. Must. Question 26 you can do on your own because they're asking you for the median. They're asking you for spread and skewness of the distribution, exactly the same as what we just did. Just do want to quickly look at question 7, 2007, question 24D. All right, you can do the distribution of the ages. That's fine in terms of skewness. You can work out the mode. And Liam, it says, decided to use a grouped frequency distribution table to calculate the mean age of students at Barry's Ballroom Dancing Studio. And for the age group of 30 to 39 years, what is the value of the product of the class center and frequency? So I'm leaving out parts 1 and 2. That's easy for you. You can do that. Part 3. Liam decided to use, now let's say, you know, the way the data is at the moment, do you know exactly how old everyone is? Yes, you do. Now, if you decide to add up all this data, you can work out the average, all right? But Liam decided to use a grouped frequency distribution table. So this is what Liam's decided to do. He hasn't really put men and women separately, so we're going to keep them together. So the grouped frequency distribution table would look like this. 10 to 19, 20 to 29, 30 to 39. That's called a class or age. Then we have something called class center, because this is what it's asking you to do. It's saying, calculate the mean age of the students at Barry's Ballroom Dancing Studio. Okay, oh, well, this is what he used. This is what Barry used, right? 40 to 49, etc. All right, 10 to 19, how many people would he have put in that category? How many people? Males and females together, please. How many people? 4. That's the frequency. How many people would he have put in the 20s? 7. How many people in the 30 to 39s? 5. Now, how do I work out, etc.? I'm not going to do the rest, all right? 40s has got 4, etc. So this is what, but they're not asking you for the whole thing, ladies. What they're asking you for is as follows. Liam decided to use a grouped frequency distribution table to calculate the mean age of the students. And for the age group 30 to 39 years, what is the value of the product of class center and frequency? What's the class center of 30 to 39? How do you work it out?
35.
Don't you go 30 plus 39 divided by 2? It's not 35. It's 34.5 if you work that out. And the question is, and that's now what we call X, the question is, what is the value of the product of class, center, and frequency? That's what we call FX. It's an exam question. It would be too much work to do it all. They just want to see if you know how to do one row of the table. So for the 30 to 39 years age group, what is the value of the product of class center and frequency? So you need to do 34.5 times 5. So FX is 34.5 times 5. Are we okay? That's 152, 152.5, I think. Can someone work that out? 172.5. That's the value of FX. Now, they don't want you to do it all, okay? Let's look here. Liam correctly calculated the mean from the grouped frequency distribution table to be 39.5. So what Liam did is he correctly calculated the mean from the grouped frequency distribution table, that's this, to be 39.5. Caitlin correctly used the original data in the back-to-back stem and leaf plot and calculated her mean, and she says it's 38.2. Who is more accurate? What is the reason for the difference? And you tell me who is more accurate. Look at this, you know this FX, that's supposedly the addition of all the scores from 30 to 39. Do you agree? But if you really add up the scores from 30 to 39, I bet they won't be 172.5. This frequency distribution table is exact or approximate? Yeah. If you add up all these, get a total, and divide by how many scores, that's exact. Frequency distribution table averages are not exact. All they've said, there were 5 people aged 30 to 39, and we're going to pretend that all 5 of them are 34.5 years old. Do you get it? That's how you do it in the grouped distribution table. But that's not the case. I'm just going to show you. Let's add up the people that are 30 to 39. So 30 to 39, if I add them up, like what Liam would have done, not Liam, Caitlin, can we add them? We've got 150 plus, do you know what I mean? 30, 30, 30, 30, 30. I've got 150 plus this 5 and 1 and 7. Does it, instead of going 31 and 37 and 35 and 30 and 30, I'm going to say 5 lots of 30 are 150, plus I'm going to add up all the tails, the leaves. 8, 13. They actually add up to 163. The actual 30 to 39-year-olds add up to 163, but the FX tells me they add up to 172.5. The FX is an estimate. Does it make sense? So what's the reason? So what is the reason? So the reason for the difference is that the grouped frequency distribution table does not use the actual, does not use each actual individual score to calculate the mean. What you could do, you could show by just adding them up. For example, the 30 to 39-year-olds, their FX should really be 163. Does that make sense? That they add up. You know, the FX is the sum of all the people 30 to 39. So it does not use each actual individual score to calculate the mean. It is only an approximation. So Caitlin's mean is accurate. Caitlin's mean is the correct answer. It's accurate. Whereas Liam, he's only saying there are 5 people aged 30 to 39. He does the middle age is 34 and a half, and he does 34 and a half times 5 to get 172.5. He's not actually adding up the age of each person. He's getting an estimate. So the reason for the difference is that the grouped frequency distribution table does not use each actual individual score to calculate the mean. It is only an approximation. All right? Caitlin's answer is accurate and correct, is the actual mean. This is an estimated mean. An approximation or estimate. So when you use a grouped frequency distribution table, that's only an estimate for the mean. Do you get it? Do you see the difference? All right. When I look at the grouped frequency distribution table, I have no idea what the actual scores are. I just know that there were 5 people between 30 and 39. I don't know their ages. So I go with the middle age when I work out the mean. All right. So we need to say that Caitlin is her median is exact, like it's, all right, yeah, she used the actual data. So Caitlin's mean is exact. Caitlin's mean is exact because it uses the actual data. Each score is counted. All right.